My name is Mark Stepnowski, student in Dr. Gregory Buckner's MAE ECE 535 class for the summer of 2019. I will demonstrate the operation of a galvanometer for you. So we're going to demonstrate the principle of operation of this galvanometer. I have a coil of approximately 160 turns of 24 gauge magnet wire, which generates a B field along the axis of the cardboard tube. And then there is a ceramic magnet, ring magnet you can see, which is suspended by several strings holding a pointer. The magnet's B field is oriented radially, and so when a current flows through the solenoid, a torque will be generated. The torque is reacted by the string, serves as a torsion spring, causing the pointer to move. To the right, there is a variable power supply which delivers the current to the galvanometer. Finite element analysis of the solenoid coil. You can see that the z-axis is the axis of symmetry. And plotted the H field. You'll notice that it really doesn't follow that theoretical derivation we did for the strength of the field inside a solenoid. It's really not long and thin enough. So the field is really concentrated right up against the wall of the solenoid. Look at the B field for the cross-sectional view. We'll see it's about maybe 0.000016 Tesla. I did a calculation from that simple design of a solenoid, which was about 120% off from what I had theoretically. However, we would expect that proportionally, field strength is still directly proportional to the current. So that electric current produces the magnetic field B. And then if I take the cross product of that alongside the magnetic charge on a magnet multiplied times the width of the magnet, which is about 6 millimeters, I get a torque. The string suspending the magnet leads to a torsional spring coefficient K. After some motion, the J theta double dot term, everything will settle out, including some unmodeled damping. And so the angle that my pointer is at is going to be the torque by the magnetic force divided by the spring constant K. Now to demonstrate the operation of the galvanometer. As you can see, I have made a few labels showing values for the current. At the moment, there is no current, and so the needle is very nearly pointing to the 0 mark. Turning on my adjustable power supply, I'm going to set it to provide 10 milliamps. Unfortunately, this is a rather limited power supply, and so it is actually only capable of providing 12 milliamps. I cannot adjust the current any finer. The needle is now pointing towards the mark that I have made for 12 milliamps. We expect that if the current were 6 milliamps, the needle would point at this mark I have made halfway between the marks for 12 and 6 milliamps. There are a number of changes that I could make to obtain finer measurements of the current. By reducing the number of coils, the magnetic field strength from the solenoid would be weaker, and consequently, I would have a finer measurement. I could also find a weaker magnet to use, which would have similar effect.